Welcome back. Last week we looked at scatter plots and correlation. This week we're going to extend the idea of correlation to find some sort of value mathematically. So we're going to do that using Spearman's rank correlation equation, which frankly is beyond the scope of this course. So for now, it is sufficient to understand that in Spearman's rank correlation equation, a rank value of 1 corresponds to a perfect positive correlation, and a rank correlation of -1 corresponds to a perfect negative correlation. In this example, Ricardo and Hannah are judging 6 Iron Chef competitors at the school. They rank each chef in order, with 1 being the best and 6 being the worst. So for example, if we look at Ricardo's judging, he says that Gerardo is ranked number 1, whereas Troy is ranked worse, meaning that Gerardo is the best chef according to Ricardo and Troy is the worst. So we can go ahead and we can graph that data on this chart here. Notice it doesn't start at 0, so this will be 1, 2, 3, so on and so forth. We're starting with Hannah on the x-axis and Ricardo on the y-axis. When Hannah judges somebody as a rank 2, Ricardo's rank is 1. So for Hannah being at rank 2, Ricardo's going to be here at rank 1. When Hannah ranks 1, Ricardo is rank 2. And I can go ahead and plot the rest of those, which I will do now. And to me, it looks like this is going to have a positive correlation. It won't be perfect, so it won't be 1 because the values are spread out. I'm going to predict this is going to be about 0.8 because the data points appear to go in a straight but not perfect line. I'm going to use Spearman's rank correlation equation in order to do this. In Spearman's rank correlation equation, to find the rank correlation, you take 1, you subtract 6 times the sum, where you add up all the differences in the judges' scores, and divide that by the number of rankings, in this case there are 6 of them, times the number of rankings squared minus 1. I'm going to start by determining the differences, then I'm going to square them, then I'm going to add them. So I'm going to use the differences here. So 2 minus 1 is 1, 1 minus 2 is -1, and I'm going to continue to find the differences here. Now I'm going to go ahead and I'm going to square those values. In this case, it seems pretty clear. I'm going to do that right here, where 1 squared is just 1, -1 is also 1, and I can keep doing that for the rest of these. So these values are these differences squared, but I want to find the sum of them. So I'm going to add them all up. So I'm just taking 1 plus 1, and 1 plus 1 plus 1 plus 1 is 6. So I know that the sum of the differences squared is 6. The rank correlation is 1 minus 6 times the sum of the differences squared, and that was 6, all over n, which is the number of rankings, in this case there are 6, times the number of rankings squared, so I have 6 squared minus 1. That's 1 minus, I notice here I've got 6 and I've got 6, so that's 1 minus 6 over 36 minus 1, which is equal to, so I'm going to use a calculator to do that, and that gives me 0.828, so I'm going to round that to 0.83. My rank correlation, 0.83, was actually fairly close to my prediction. It's a somewhat strong positive correlation, but it's not perfect. So problem number 3 is asking us to comment on the degree of agreement between their rankings of the chefs. 0.83 is fairly close to 1, so therefore we can say there is a fairly strong positive agreement between the chefs. So we can say that because R is positive, the judges tend to agree rather than disagree. Thank you for watching this video. If you have any questions, go ahead, feel free to send me an email or contact your other Course 3 teachers. We will be responding during this at-home learning to all your questions during the scheduled hours.